Hello, everybody. We are about to start, and I'm Evgeny, the founder of SimpleX. And we have Dan Keller with us, the founder of Flux. Dan, hello.
Hey, how are you, buddy?
Good, good. Hoping everything is working, and we'll have an hour. I have lots to share, so we may as well start. Give us a second. All right. So, SimpleX Network, power to the people. And we are about to start. Thanks for everybody joining us today. That's fantastic to see so many people interested in what we do, and we have lots to share. We have a huge plan. The title is clearly wrong here. Obviously, something should talk. We'll talk about what we did so far, encryption, security, and connection privacy, and what we call extreme decentralization, and why Flux joins us in this journey and how it helps the privacy and how we're going to make it profitable and how communities will grow and about moderation and freedom of speech. Lots to talk about. All interesting subjects. So, SimpleX network, where we are now. So we've been working on this network for 3 years now, and we built a lot. And at the core of it is securing your messages with end-to-end encryption. That's a huge subject. Usually, most people don't understand what risk and attacks it protects from. So we wrote a lot about it, but we try to protect all possible attacks on end-to-end encryption security with various components of it. And I believe over time, we have managed to build one of the best in class end-to-end encryption implementations that protects from all the attacks and attack vectors we can think about better than existing alternatives. So with message padding to a relatively large size with full stack repudiation, with forward secrecy, with break-in recovery, with mandatory two-factor key exchange, and with post-quantum cryptography, which rotates the key on every message direction change. But what the main premise of SimpleX network was about protecting connections privacy, to protect who we talk with and when and why, etc., etc. So why personal privacy is important? We see a lot of polarization in information space, and we see lots of people being like manipulated by information, being fired from their workplaces from sharing their opinions, etc., etc. And also the prices we pay depend on knowledge of who we talk to and when. So this is all critically important for normal people to keep your relationships private. And what we used to call metadata privacy, it's really our privacy. This is like very famous quote, how metadata can be used against us. Obviously, it's not something that ordinary people would ever encounter, but we pay high prices. We see different things on the internet depending on our connections and relationships. So that's the core of our thing, was to protect who you talk with. Because we see that majority of communication networks see privacy as something like this. We'll protect your communication content, but we obviously know who you talk with, when you talk with those people. We can monitor those conversations, but don't think it's privacy at all. So how did we do it? So, and again, I'm going to repeat things some of our users probably know, or many of our users obviously know, that's why you're with us, but there are also some new people, so we will repeat those things. So most networks rely on user IDs, but the problem with that is that if there is some pseudonyms, some numbers, then by comparing it with public network, you can determine who is who, and that kind of compromises privacy. That's why we built it differently. So the way we see, like hundreds of years ago, we had this kind of design of communication network. And yeah, we put the logs, we removed the names from the boxes, but fundamentally it's the same. There is a person, there is a box for this person to receive messages. we did it differently. We, instead of attaching identifiers to the users, we attached them to connections between users, as obviously all our users know now. And that hides information about who talks to whom from the servers and from the network. And from the server's point of view, that's how the network looks like. And this is the metaphor we see in comparison with the old mailboxes. But there was a problem, right? And that was one of the biggest point of criticism of SimpleX network, that because you connect to the server that receives messages, this server can observe your IP address, and it kind of can de-anonymize users and servers can figure out who talks to whom via the IP addresses. And we did solve this problem last year. It was one of the biggest innovations in the network by creating the new design that protects transmit information via private message routing. So I'm going to walk you through how it works step by step. So because I think we've never made this detailed presentation of how a network works, how encryption in the network works, and this is the interesting bit. So we have let's say Bob on the left and Alice on the right, and they will exchange messages, and you will see all the layers of encryption and servers that the messages come through when they exchange messages. So you see the Bob wrote the message, it got end-to-end encrypted. This gold brick is your end-to-end encrypted message. Irrespective of what the message size, it becomes the same size as soon as it gets encrypted. And that's why servers cannot see the difference between a short hello or a link preview or even a picture, because files are sent separately. But then it happens, a separate additional encryption layer is applied, and this is the layer that will only be decrypted on the destination server. So, and obviously Bob connects to the server he trusts, right? And it's chosen by Bob. And this server applies additional encryption layer. Why this encryption layer is needed? So this glass tubes is obviously encrypted TLS, right? It's transport level encryption, but we don't control this. While we use the additional level of security that TLS provide, we make assumption that TLS can be compromised, and we do not really control TLS, and therefore we apply additional protection. So in this way, you see that when the message before the server and after the server, they encrypt it differently. So if whoever can compromise TLS, they wouldn't be able to establish it was the same message, because that is completely different from the point of view of whoever observes inside TLS. However, they were able to compromise. Okay, and then the message travels to the destination server. And because this additional encryption between the user and the destination server, this blue color, right? The first server doesn't really know to which address this message goes, right? And the destination server, it knows to which address the message goes, and it can decrypt it now. You see, it removed this blue color, but it doesn't know from whom. And then obviously it goes to Alice, and again, this applies one more additional encryption layer so that whoever compromised TLS cannot see that it's the same message. And then it gets decrypted for the Alice. And Alice replies in the same way. When she writes a reply, it gets end-to-end encrypted, then it's encrypted to the destination server. The same layers are applied and removed. And this is really how the message routing works in the network today for all users non-optionally, right? So, yeah, and then that's how they talk. So what's important in this, it's effectively onion routing, but it's different from onion routing that we have in Tor, because in Tor, we connect circuits, right? So all the traffic sent by the same user to the destination, destination can see that it's coming to the same user. And for example, if Bob would message multiple people on the destination server, this destination server will not be able to establish that all these messages come from Bob. They would see them as messages just coming to some different destinations, but they wouldn't know whether they come from one users or from different users, because the first server would make them packets. It's effectively close to mixed network design. Like NIM, for example, is designed somewhat similarly. So packets are routed in this network rather than the connections. So it not only protects IP addresses from the destination server, it also protects transport session identity. So when Bob, the person on the left, messages multiple people on the destination server, this destination server wouldn't know if it's the same sender sends them or different senders. So like servers with these two-level routes and lose the ability to see who communicates with whom. Hope it makes sense. Watch it later. And that's pretty much where we are today. We created the best-in-class end-to-end encryption, and we created onion routes for packets, specifically for this messaging network. Where are we going? So we believe that people should control their communication, and that's why we used power to the people as the tagline for this live stream. And we believe it can only be achieved via extreme decentralization. What do we mean by that? And why decentralize at all? So let's talk about it. Because decentralization doesn't really help privacy as such, right? Because we've seen it with federated networks. Fundamentally, decentralization helps two things: being in control of your communication and preserving your freedom of speech. And historically, we've seen several models of decentralization. Obviously, it all started from, well, it didn't start. At some point, we arrived to centralized network dominating, and they provide different level of, they all provide bad control, your account can be deleted, etc., and you have different level of freedom of speech. But in any case, you're completely at the mercy of the owner of this net. You can call it network because it's network between people, but in reality is we have a huge centralized provider. Whether you like them or you hate them, it doesn't really matter. They own your communication, they own your content, and they, in a way, own you. They can deplatform you in a second, and there is no recourse. And that's why we moved to federated networks, and we were hoping that we'll get more control, and we did to some extent. But the problem is that we reached the situation when we have less freedom of speech and more opportunity for censorship, because if previously only one operator could censor you, and obviously if they censor you too much, they can go out of business, etc., etc. But when you have lots of small servers, the censorship can be applied in a variety of ways, right? So first, wherever you open your account, this server can censor you as the account owner. They can block your account, or they can, but they can do more. They can block uncommon content as well. We'll compare it. So what we've seen, I think one of the biggest innovations that happened recently was Nostr, right? That said, all right, we're just gonna put every piece of content to multiple servers, and that would prevent censorship. The problem obviously is that Nostr model is fantastic for censorship resistance, and it's very bad for privacy. Where does it put SimpleX chat? I think we're somewhere here at this point. We kind of give users a lot of control about choosing which servers to use, but because there is no redundancy in message delivery and there is quite a dependence on the server that you choose, it's much worse with censorship resistance than Nostr is. So how in this model we protect from failure and abuses of power by various network operators, like ourselves or like Flux or whoever servers you choose? How do you protect from their choices? So again, if you compare federation versus decentralizations, what we know about federated operators can block users, they can disrupt connection, and they can censor any content. Not only the content that is hosted on the server itself, but also the content that you search on other servers, or they may decide that you can't follow certain accounts on other servers. Obviously, this power is not, but we've seen some abuses of power in federated network when servers, like for example, server operators are openly discussing that they should, for example, defederate servers if some big tech starts hosting those servers. And that's kind of both interesting and worrying that such things are discussed. So with SimpleX network today, we already are in situations when operators can't block users and connections between users because operators simply don't know who are the users and which connections are between whom. So short of blocking all connections, they can't block particular connections. But obviously, operators can block users and group addresses on their own servers. I mean, multiple time use contact addresses when you connect to somebody, or group address, it can be blocked. And they can remove content from their own servers, which is better than federated model, but it's still not resistant to censorship because it means that every single operator can remove the content that was posted to it. So, and with extreme decentralization, we want to be in a situation when not only the operators can't block users and connections between them, they also cannot block addresses individually. So effectively, if address depends on multiple operators, only if multiple operators together decide to block some address, then it will be blocked. Similar to Nostra model. And same with content, right? Like if one operator decides that the content is bad, then it would have no impact. But if all operators together decide to censor something, then it will be censored, which is close to Nostra model with obviously some differences. And that's the model that we want to go through. And for that, this is critically important that multiple unrelated companies are present as operators in a network, and people can choose to use not just which operator to use, but to use multiple operators at the same time. So we can move to both private and censorship resistant network model. And that's why end of last year, we made agreement with Flux, whose founder we have here, and super excited to have them as yet one more network operator. And then over to you. Please tell us why did you do it? Why do you think what's Flux? And like over to you.
Yep, absolutely, and unbelievably educational walkthrough there. That I would recommend anybody that's looking at the platform to listen to this and listen to it good, because one thing I think you really emphasized was privacy, and really that's why Flux was born. We want to be able to give that decentralization, that privacy back to these projects just like yours, and have no single one point of failure. So let me talk for those folks out there. You know, we saw like a 50-50 split. 50% of the people were unbelievably ecstatic about this. They see the benefit of running on Flux in a decentralized manner, deployed across. I think we're in 80 plus countries right now, and as we continue to grow out this project, decentralization is at its key part. It's that our motto is for the people, by the people, and it goes well with yours too. So I had a chance to sit down and really dig into what SimpleX was doing and how it was going to impact the current tech models, and it was a no brainer for me. I wanted to be part of it because I think this is an unbelievable value add. So what is Flux? We're the leading decentralized infrastructure platform. We're bridging providers and users of compute storage and resources. So there's many facets to Flux, but the one thing you have to understand is we're built on open source technology. Um, uh, Anyone running infrastructure on Flux has full end-to-end encryption. So we actually have a product called Arcane that will start to kick off more development with SimpleX, and that provides any users that utilize the platform with end-to-end encryption. We also have thousands of providers across the globe. The individuals running the Flux network, or as I call them, decentralized systems administrators, they focus on the growth model. So you can see here we're actually in these numbers are a bit behind, so I'll update them as I go. We're actually in about 80 plus geographical locations. We've got better part of almost 1,000 providers at this point in time, spread globally across the world. We have about 13,000 decentralized nodes, about 140,000 CPU cores, about 300,000 plus terabytes of RAM, and we have about 8 petabytes going on 9 petabytes right now of storage. So what does this mean to you? It means this network was built for one focus and one focus only. It was for folks like SimpleX to develop platforms on, or as we call them, Web 2.5, to become more integrated into Web 3. We have seen a paramount increase in deplatforming of people that don't like your political opinions, they'll remove you from your platform. They'll block you. They'll, take down users. You look at what happened to Telegram, and the same people that are arguing about SimpleX and building out their decentralized network are the same people that are continuing to use Telegram. So don't do that. SimpleX offers clearly a more robust, more structured process, and it takes privacy to heart. So they're not going to be able to really attack this platform like they have in the past. Next slide. Do we have a next slide?
Yes, we do have the next slide.
Sorry. So what is that? So where does Flux come from, and why does this matter? Flux is, again, the world's largest decentralized compute network. You can run front ends, back ends, game servers. We have Flux AI components that we just built out, so on and so forth. This is a perfect place for Flux to be because it starts to demonstrate how people can run their own networks effectively. You've heard people use the term DPIN. This is truly the definition of what DPIN is. It allows people to run on a platform that is not censorable, built on Bitcoin technology with fully integrated deterministic nodes. So what is Influx? Influx is the parent company. What does that look like? Well, we've got 75, probably closer to 78 employees. We have more than 25 people that are currently working on commits, all open source commits across the board. Our GitHub contributions they speak for themselves. If you guys are interested in what we're doing, please check it out. And we're continuing to build technology that matters. So what do I have to say to the people in this audience who are listening, who were naysayers when this was announced? This is everything you've asked for and then some. It continues to build the new foundational groundwork for the paradigm shift that is privacy. We've continued to build products out that rely on legacy technology. So that's a pinch point. If we build it out and deploy this on AWS, well, now we're at the mercy of AWS or Google or Amazon, Microsoft Azure, whatever it is, right? So in reality, we have to now begin to lay the foundational groundwork to work ourselves away from those dependencies that we have on Web 2. And we can always be more decentralized. We're going to really focus on growing out that decentralization and privacy footprint with SimpleX. We're going to make sure that they have all the tools and resources they need to meet those goals. It's very difficult to call yourself a privacy-based decentralized platform and you run on AWS or Microsoft Azure. So this is a total paradigm shift. This is going away from conventional legacy infrastructure and working itself into the new version of what Web3 will absolutely be. And I'm super excited to see this continue to transition. I mean, you get me pumped every time we talk about it. I think the people that are out there right now that are listening to this, that are still naysayers, get your head out of your ass, guys, because this is I mean, seriously, come on, guys. This is literally what you have asked for and tasked this project with, and now they have a partner who is willing to build out all the things they need for that high level of security, privacy, and now decentralization. This is the trifecta. So I look forward to your questions. We can clarify anything about Flux that you have. And I'll hand it back to you.
Yeah, thanks, man. That's a huge vote of confidence. And I think we obviously not going to stop where we are, and there will be more servers, I think it's critically important because as you've seen from the design of the network and how messages are routed, then obviously if the same company, SimpleX Chat, controls both first and the second server, then you effectively, whole security model is based on trust, right? You have to trust us not to combine data from those two servers to determine who talks to whom. And obviously you can run your own servers, but absolute majority of the application users would not use their own servers. They would use whatever is pre-configured in the app. And now, even though it's still opt-in and we're still stabilizing operations, stabilizing the servers, and people have a choice to use both operators at the same time, And if you, when you install the app, if you enable both SimpleX and Flux servers, and you should do it, then every time you deliver a message, it will go through two different operators, and it means that your privacy is protected, and neither of us individually can access this data. We'll have to effectively collude. I'll have to come to Dan, and we'll have to make something criminal to effectively find out who talks to whom. And we obviously don't want to do anything. But not a single company can quietly analyze their data and learn who talks to whom, which is very important. So that's why. But how, okay, but how, obviously neither of us is altruists. We all have the bills to pay, and Flux has the bills to pay, and we have the bills to pay, right? And how do we see making these operations for network server operators profitable? Obviously, network is still early stage, and there is still a lot of work to do. But the answer is very simple. Like, nothing new. We don't think we have to absolutely innovate everything. Freemium models work, which means obviously there are bad approaches to premiums, like Telegram premium is completely horrible, and I'm not going to do the same. But at the same time, there are good approaches to freemium. For example, look at Dropbox, right? So you have some free tier service that's quite usable for casual users, but if you want some advanced features or more capacity or whatever, you have to pay something, and it works. And obviously there is business services that businesses pay for. And there is another opportunity. I think we can also include ideas around selling content or digital goods or whatever privately. So, and I think we're still at a stage. One of the questions people ask a lot, right? Why the hell it's called SimpleX chat, right? Isn't SimpleX is it SimpleX or Simplex? People ask us, right? And what the hell is, if you're in North America, then like half of you think that Simplex is a sexually transmitted disease, right? Clearly, but we think we're still very early stage network that has kind of lots of growing pain and limitations, and it makes it fantastic for enthusiasts, but pragmatic users will get to Q&A. In the end, one of the questions was, when guys, you will make I/O authentications work well? We will, absolutely. So it's still early stage network, and it's a bit too early to decide how we're going to cash in, right? We have to make it work. We have to make technology work. We have to make notifications work. We have to make large groups work. I'll talk about it a bit later. And obviously, when it's ready for like pragmatic users, the brand probably has to change as well. And obviously, it's SimpleX for everybody who doubts, right? And the original name SimpleX Chat comes from Simplex Communications as opposed to Duplex. As you've seen on this video, messages travel in one direction only through the network, and it's only users who know that these two message delivery paths form a conversations, but servers don't know that. For servers, the whole network is unidirectional. That's why it's Simplex. And we obviously made a pun that it's SimpleX. Right. And then the question users ask, okay, fine, we want to pay for that. How are we going to pay for products and services? Doesn't it mean that if we pay for something, then we automatically lose our privacy? So, for example, if we look at traditional blockchain designs, then obviously there is no financial transaction privacy. How are we going to protect privacy if we pay? So we don't have a final design. We have a concept design. I'm going to show it. So don't see it as a committed and final design. It will change a lot, and we're not going to start implementing it tomorrow, but it will give you a glimpse into the future that we see as very exciting. So I know it's a lot. It's a complex model. So effectively, it's a multi-operator network that can issue and accept what we call infrastructure vouchers and use zero-knowledge proof when accepting them. So you can come back. I'm not going to spend a lot on this complex diagram. It's explained in the document. You can come back to the video. But fundamentally, the whole point here is that when users decide to pay, they buy vouchers from one operator. Obviously, it happens transparently through the client. It's like almost like paying for gas, right? And these vouchers will be then presented to whatever operator you are using to send files or to receive messages. and validation would not expose your identity. Obviously, there is no such thing as private payments today, right? There are some attempts, but fundamentally it's incompatible with existing legislation. But because we see these infrastructure vouchers as not money, so for example, you wouldn't be able to buy these vouchers and sell it to somebody else. You will be only able to use them within the network. So they are closer to gift cards than to money. So we believe that we can provide financial transactions, the privacy of utilization of the network when your purchase of those vouchers cannot be connected to your usage of those vouchers. And cryptography exists. There is no cryptography innovation here. It's the same zero-knowledge proof as used in Zcash, for example. But fundamentally, it's about wiring the network, creating the system of relationship with operators. And that's a very long, multi-year initiative that we're going to kick off sometime this or early next year that will create a mechanism to effectively accept payments without losing privacy of whoever pays. Dan, maybe you want to comment on that. I think I've shared with you a diagram. If you can say.
Yes, and I think that's a very astute observation. I think that as far as payment goes in the voucher system, I think this is the cleanest way to do it, so that you're not creating another surface area to give your information up. I think this could look a little bit different, and I know people will say right away, well, what about privacy assets, Moneros and Zcaches and so on and so forth? All great in their own right, but historically, as he was alluding to, they're not necessarily favorable for different regulatory regimes, so to speak. So I think this gives us the opportunity to kind of meet both demand plus regulatory security. So in my book, I think this is a win-win. And I definitely think that as this continues to grow, I know on the Flux side, at least, I think as we get better regulatory guidance, I think you could see this expanded to privacy-based assets at some point, but not till we're feeling like 100% confident that that's where we need to be. There's no sense to bring ire to the project when it's not needed. And let's face it, anything that's really being developed around privacy like this, it can draw ire. It can draw people that, can definitely create havoc. We're going to build it so that we don't have that. We check all the boxes, dot all the I's, and cross all the T's. And that's exactly what this structure will help us with.
Thanks, man. Yes, so we absolutely don't want to create yet another cryptocurrency, but we want to find a way. And we'll move to participation privacy, but I want to say, I always wanted to be able to buy books and movies without people knowing which books and movies I watch, because ultimately the knowledge about what information you consume is used against you, right? It's used to sell you other things you not necessarily want to buy. It's used to so this model may allow things well beyond paying for infrastructure, right? It may allow content creators sell their content, or book authors selling their books without knowing who they sell to, right? And that's very important, I think. So, but we'll move on. So we want to make public channels and communities finally work. We learned that people want to participate privately, and which was a surprise originally. And even though it's kind of almost an oxymoron, like it's a public group, why we want to say it privately, but we talked about it because freedom of speech depends on our privacy, our ability to say. So, and we learned that fully decentralized groups we created, they really don't work, they don't scale, they're not reliable enough, and we want to move to the model for public communities and groups which has super peers. So the problem, as you remember, you can watch our previous live stream that was more than a year ago. The problem is that if the group is fully decentralized, then everybody has to connect to everybody in the network, and some connections break, and then those users then don't see messages. And we solved this problem partially. So for example, if connection doesn't form, we use admins in the group to forward those messages. So the current model is an evolution of fully decentralized, right? So like when you connect and you didn't connect directly, your admin will forward messages temporarily, but it still doesn't scale, right? Every time you see them send the message, it has to be rebroadcasted to every other, not broadcasted by your client to every member in the group. And if there are like 5,000 members in a group, then it's a hell of a lot of messages, right? So we want to move to this model when there are dedicated members effectively who participate in the groups, who the group owners choose, who rebroadcast messages to other members. We will be providing those super peers in network, but they will be normal clients. You can run them on your desktop with good internet connection, and you can have as much control of the group as you want. So you will be able to build such groups completely yourselves without us, or you will be able to use our super peers. We already developing this technology. We talked about it like for 2 years now, probably, but lots of components landed. But this is happening. This is happening now in 2025, and you will have channels with comments, better moderation tools, and all these huge things will happen. But moderation is actually a very, very controversial subject, and we'll talk about it. So why, like, how can, like, I keep hearing the same question from our users. So how can you talk me both about freedom of speech being so important and at the same time talk about moderation? Isn't moderation in any form contradictory to freedom of speech? And I cannot disagree more with that. I really believe that moderation is helping freedom of speech, and it's absolutely necessary for freedom of speech. And even I would say, take it one step further, that absolute freedom of speech is effectively the tyranny of the most vocal group of people. So it's not a freedom at all. Imagine you're trying to have like a presentation to a group of people, and then suddenly people who disagree with your presentation barge in and start shouting and waving flags and say that you're a bad person. And obviously it suppresses your freedom of speech. So we want them to have this demonstration, of course, but in some other place, not where we're trying to have a conversation. So while we don't want to have a global censorship, we absolutely need to have local censorship when group owners can impose some rules on their groups. And likewise, like ourselves and Flux, our organizations that have some responsibility for what happens on our servers, we also want to have some ability to impose limits on what is happening. And our view may be different, it may be dependent on jurisdiction, but that's absolutely necessary for being able to provide freedom of speech. How did it traditionally happen? Traditionally, when users are identified, then it's all very simple. If a user does something inappropriate, then servers simply block them, and they can't use the servers anymore. And it's all very simple, but we just spoke that identifying users is bad, it compromises their privacy, it abuses them, so we can't really use this approach. And we know that the kind of existing consensus, it always was a consensus, so you really cannot moderate without identifying users. That's what I heard from many of our investors, both existing and potential, and my reply was always like, watch and see us do it, we'll figure it out. So, and also what's important to understand in this context that there also was a previous consensus, right? That delivering messages without identifying users is impossible. Like there must be, like when I came to the market with the idea that we're going to build a network that users are not going to be identified, like everybody was saying, man, you must be lying, right? Like this literally is impossible. If to deliver a message to somebody, you have to attach a number to this somebody, right? It may not be a name, but you need a number, and if you don't have a number, you can't deliver messages. I heard it like unlimited number of time, and yet we have a network when I'm not attaching any numbers to any users, and we're delivering messages. So we believe that it's possible. So, and we can build privacy preserving moderation in a way that also restricts activity of the users. And we've been talking to the users about this direction since beginning of the year, and it's hugely controversial. We have lots of love and support, and we have lots of criticism, and I would say even hate for even talking about that. from freedom of speech absolutists who believe that moderation is a bad thing. But let's first talk about how will it work, and then we'll comment on why it's a good thing more. So let's say we have some user who wants to say something that another user would strongly dislike, and it sends this file, let's say, containing inappropriate content to the server. And obviously, the server doesn't know who the user is and what the file is. It will obviously deliver it to the destination, and it naturally will make a user who received this content unhappy. So what can we do about that? We don't know the users. We don't know what's inside files. We can't scan files. It's technically impossible, and it's even illegal to scan kind of all content. But the user can then complain, obviously, say, oh, look, there is this group and there is inappropriate content in this group, and I want you to look. We do have complaints from the users. But at this point, because the user shared the information, operator can now access this information and can validate the complaint. We can enter the group, we can look inside, it is no longer private content at this point because the user shared the access point with us. And if operator agrees with this complaint, because obviously there will be frivolous complaints, users may just dislike that there is a group discussing like what's the most controversial subject today? Okay, let's say group discussing that Democrats are bad people, or group discussing that Democrats are good people, and there will be unhappy people about these discussions, but it's all within the boundaries of free speech, and we don't want to moderate either of those discussions, right? And there will be a million of subjects that we wouldn't want to moderate, even some people disagree. So we can't just block everything that users complain about, and we won't. But there will be some things which we don't want to participate, and there are obviously known examples, and there would be crimes against human trafficking and child sexual abuse and whatever that we do not want to participate in any shape or form. And if users send complaints about that, we would say, yeah, we want to block it. We can delete content in this case, but it's usually inefficient because if we simply delete content, users shrug and create another group, upload different files, and act as if nothing happened. So this is obviously a game of whack-a-mole, can continue forever, and it doesn't really lead the results. But what we can do, when the client uploads the file, if this file is blocked, the client will learn that the file is blocked. And we can program a client in a way that when the client learns that the file is blocked, the client application will refuse to upload further files because it is harmful to our servers, it is harmful to our users, and we do not want such files to be uploaded to our servers. So the client programming will prevent uploads of further files. This has never been done, don't get me wrong. And this has lots of criticism, and we'll address them one by one. Obviously, but let's talk about further how it works technically. So at this point, if client will simply refuse upload further files to the same servers, to the servers of the same operator. And obviously not just to this particular servers, but all servers that are controlled by us. Right. So what critics say? Can't users modify their client? Absolutely, they can. But the recipient clients would still know that files from these clients were blocked, and without identifying the users, they would refuse to receive further files in the same conversations. So it would have somewhat limited, but still in effect. Also, modifying clients is complex, and the majority of people won't do it. So even though it's not an absolute measure, we see it as creating sufficient friction for people who may want to send inappropriate content, not to bother and use some other means of communication. Now, can't users use other servers? Of course, they absolutely can. And we see it as a good thing. Because if we apply some restrictions unreasonably and block content that, like, appropriate, okay, that may be our right to prohibit this content, but it doesn't mean that other operators must be prohibiting the same content. Maybe we are in some country that, like, has some views on content that are different from what's universally acceptable. So the fact that people can use different servers and not be blocked on those servers. It's a very good thing. That's how it should be, right? So client kind of respects the view of the operators that this particular operator don't want this content, but some other operator may be okay with this content, and that's a good thing. And that's exactly what I was talking about extreme decentralization. When client chooses to use multiple operators, only things that everybody thinks are bad will be blocked. Because, for example, if you send a file via multiple operators, okay, we can block our part, but if some other operator doesn't block it, then it will still be not censored. So that kind of prevents us from, obviously we want to be in business of delivering files, right? If we block files unreasonably, we will be out of business. So that kind of creates a balance of power between users and operators, that users can use, not just choose the servers, but use multiple operators to send one file via multiple operator. Right. And obviously, who decides what's appropriate and what's not? Obviously, it's a layered safety level, right? So the first and the most important, user decides what's appropriate for them, and we already have the function in a group that allows users to block any member of the group individually. So the group may think that this user is behaving okay, this member, and the member will not be blocked, but a user, a particular group member, may say, I don't want to see their messages anymore, they're annoying, I don't like them, I don't like their face, I don't like the name, I'll just block them. That's already possible. So I think the user should take priority. And then the next layer is community. Like community may say, whatever you do here is not appropriate for this community, go away. And then the last line of defense is server operator. Server operator say, we don't want to participate and deliver this content. And then they go back to why it's a good thing, right? So operators can't block users, can't disrupt connection, and can only censor content if there is a collective action of multiple operators. Obviously, network design is not there yet, and that's a lot of work to get there, but we are talking about destination, where the network is going. And that's why we say it gives power back to the users, to the people, because ultimately operators become a disposable and replaceable commodity in this network design rather than somebody who holds any power in this network. And then the last argument, doesn't it contradict the idea of general purpose computing? Yes, it does. And it's actually a great thing because we'll get to it. I personally think that general purpose computing is an obsolete concept today. Like, for example, many people quote Cory Doctorow, who is a staunch advocate for general purpose computing. But we now live in a world when computers are cheap and information is expensive and humans matter most. So if we design our systems around computers that are allowed to do harms to humans, we're going to be replaced. And it's very scary. I want to go back to as far as like there was this Isaac Asimov. He's a biochemist and more known as a science fiction writer who formulated 3 laws of robotics. So I think apply here. And general purpose computing is simply reflecting of the second law of robotics, that a robot must obey the orders given it by human beings. So, and it's great, but there was the first law, that a robot may not injure a human being or through inaction allow a human being to come to harm. And I think this idea of client-side restrictions we're discussing is effectively a very basic and limited implementation of this first law of robotics, when the application that you run of your device will restrict your actions if these actions are seen harmful to other users. So this is all in line with the ideas of Isaac Asimov of not allowing robots to do whatever their owners want. We don't want to live in a world when robots do what their owner want, right? And there was also the third law about robot protecting its own existence as long as it doesn't contradict with the first 2 laws. And this all goes back to a very wide subject of defining ethics of artificial intelligence and computers. And Asimov formulated it more than 50 years ago when, like, that if we don't define those ethics, if we don't embed some moral judgments and layered frameworks into robots, then chaos will follow. And that's exactly where the world is today. There's a large debate about it. And so that's what I think about it. So I think that privacy preserving moderation will protect users, will protect freedom of speech, and will also protect network from abuse without identifying users and without enabling any abuse of power by the operator. So that's where we're going. That's the network we want to build. And there will be criticism, there will be lots of support, and that means that we're doing the right thing. We are at the end of what we want to share. Dan, do you want to comment something about it before I come to questions?
No, I think you handled it really well, man. Well presented.
Thanks, man. Okay, we have lots of questions. Let me find them. Thanks for sending all of them. I'm not promising to answer all the questions, but we'll go on for 20 more minutes probably. So I think I answered why I think this shouldn't be abused, because if multiple operators are used for groups, there was a question. You can see all the questions in the group, by the way. We shared the link to join the group. I'll answer simple questions first. Will there soon be channels like Telegram? Yes, we'll be building it. IO notifications not working. We know that the last beta release fixed one of the problems with notifications. We know at least of 3 more problems with IO notifications that we need to fix. We already see it working more reliably with the last beta, and we really hope to get it to highly usable level this year. Is there a plan to allow desktop app to function whilst not on the same network? Absolutely, yes, it absolutely has to happen. Message timestamps in 24-hour time. You can do it via the system settings, but maybe we'll make it in app settings. Voice change, audio video calling. Audio video calling is a very complex thing. We will be improving it, but probably. Oh, this is a big question. Reproducible builds. I will explain what reproducible builds are. So there is this concept in information security that open source code is only good if you can build the binary yourself and you will arrive to exactly the same bit-by-bit identical binary. And this is a complex subject because compilers introduce lots of non-deterministic outputs in the binaries, such as timestamps, such as random identifiers, and particularly the compiling stack that we use, Haskell compiler, it's fundamentally non-deterministic in general. So we see that it's absolutely possible, and it is a priority, and it's an expensive initiative, so we are not currently prioritizing it right now, but we absolutely will get to the point when not only it's possible to reproduce build bit by bit, that is, if you build the binary yourself, you'll get identical binary as the same as you can download from any source. But we also want to be in a situation when multiple security researchers, either because they love us or because we sponsor them, actually do reproduce old release builds, right? Because I think reproducibility is not valuable unless it's continually tested by people, and you cannot just see that, yeah, I can reproduce the build if I want to, because I really believe that nobody will do that, right? I mean, some people will do it, but majority of people will not bother building their own applications. And instead, what we want to have is that actually more than one person does it and publishes the results and signs the results on every single release we make. I cannot commit to a date. It most likely won't happen this year. It very likely may happen next year. So that's where we are in reproducible builds. SimpleX currently doesn't.
I just want
Go on.
Hold on 1 second. I just want to address, because I've actually been in the chat for YouTube, and I just want to say one thing. I think people need to understand that anytime you are at this level, a founder is put into a precarious position because you have 50% of the community that want you to go one way, 50% that want you to go the other way. In the end, we're all heading to the same place. It's just the timing and how we get there. So, I would say this: instead of complaining about how the product is being developed, be part of the community and provide solutions and input. Being creative and not being destructive as people are working through this process are absolutely imperative. So I hear everything you guys are saying, and we enjoy the input. And by the way, these are learning points for us just as much. This technology doesn't exist. You guys are disruptive technology innovators. That's what you are, and that's why you're here. Your words that you speak hold power. They hold power in the direction of the project. They hold power in the community and how they perceive it. It is your job to represent this project and provide creative criticism across the board. So if you have creative criticism that you want to give input to, I can guarantee you they're willing to listen. But if you are demonstratizing or making something that out of nothing, there's no value in that. So let's just all be super creative, because this literally is for the people. We make no money doing these things. We're building these products out because we believe in privacy, we believe in decentralization, we believe in having the people control their destiny, their data, their input, their privacy, not big government oligarchies. So, I appreciate your input, and we're going to take all that to heart. Let's change that mindset. Instead of being negative, be positive. Help them get to the next level and not hinder them.
That's
I just wanted to mention that before.
No, that's great. I 100% agree. Look, I don't mind a bit. Like, I'm probably myself all doom and gloom, maybe because I'm in this gloomy island. But yeah, I think we learned a lot from our users, and when users make practical and implementable suggestions, we implement them on the spot. But certain things are either expensive or complex, or they require some sequencing. And yeah, that's what we do. So anyway, so what was the next question? SimpleX currently doesn't hide online presence when users are in a group because automatic handshakes happen. Yes, super peers will address it. And there's a comment. And the question is, how do we hide it in small groups? I think the answer is very simple. You don't, right? You have a choice. Either you use super peer that the whole group trusts and it hides online presence, or you trust each other and it's a really small group and there is no need to hide online presence, and then you don't need a super peer and you can communicate all directly. So I don't think it's possible to hide online presence in really small groups that are fully decentralized, because you're right that there will be happening handshakes, and there will be some events that happen between members, and there will be some indications of online presence in small groups. So, and that's why we're building this solution with super peers, because they will provide privacy and they will allow scheduled delivery, and they will hide your online presence, and they can even make it that messages delivered not when you're online but later. So that's a choice. It's almost like you can't have your cake and eat it. You can't avoid a server and at the same time be protected from your peers, right? Super peer is effectively a mini server in a group, and it protects you from other members. In the same way, messaging servers protect you from people you message to, the group presence will be protected by those super peers. So there is no way to avoid this choice. The next question is good, actually. Will super peers be able to change the content of messages without other clients noticing it, man-in-the-middle attack? Absolutely not. And we have a cryptographic solution for that. Like, every group, maybe not on the first release, every group will effectively be a Merkle graph. Think like the same cryptographic model that's used in IPFS, but on the scale of the group. Which means every time you send a message, you include the hash of the messages you've seen before. Not all the messages, but the parents, right? So let's say you received one message, you include. So effectively, it's like blockchain that diverges and converges back. It's directly a cyclic graph, which allows all members to validate integrity of the transcript and that all members see the same content in the group. Plus, the groups will support having multiple super pairs. So even if one super pair will try to replace the content, another will not, and it will very soon be detected, right? Plus, on top of that, some important messages, let's say the decision to change the group profile or the decision to change the group role that only owners of the group should be doing, they will be signed by owners, cryptographically signed, and the keys will be published as part of the group profile, and they'll be outside of super peers control. So tomorrow we see super peers effectively playing role of rebroadcasters and not even being able to moderate content unless owners instruct them to. And obviously, if you use only our, and again, that's why you need multiple operators. So for example, there will be super period that we run, there will be super period that Flux run, and you can run your own. So, and in this way, even if any of super pair operators will try to abuse this position, it will be very quickly found out and it will be discovered by others. So that's a good question. And we absolutely know that this is a problem that has to be solved with this new design. Right. Fight. Do we remove content which is complaint? Will we kill queues? So effectively, the question was about our current moderation efforts. So we process users' complaints. If we believe that this content is inappropriate, we delete access points to the groups, we delete files, and we also delete addresses of any bots or directories that distribute content that is illegal. So yes, send us reports, we're acting on them. We have a process for that. Current client-side restrictions, for example, file size limit, are static and within the app itself, whereas the new client-side restrictions are applied by the operator. How does the client receive the information to apply restrictions? It will be included in the file itself. You send the file, you want to check its status, you will see that it's blocked, and that will result in applying a restriction. Or recipient receives your file, sees it's blocked, shows the users the notice that the file was blocked by the operator, it will apply restrictions that further files will be blocked. It will be possible to appeal it, it will be transparent to the users, it will be like effectively, if it's by mistake, it will be lifted. Yeah. How would the team react if the government forces? I'm not engaged into such questions. We exist obviously in a jurisdiction of questions. We will communicate with all the official requests, but how we react depends on the requests, and it's effectively almost like asking to disclose my legal strategy. We have a legal strategy. We have fantastic legal advisors. We are well prepared to engage if needed. And our ultimate priority is to protect our users within the boundaries of the law. And whatever is possible to publish will be published in transparency report. But I cannot explain all the possible eventualities. I would direct you to our privacy policy. It has notices about, we explicitly state in our privacy policy that we didn't have any requests so far. If we do have any requests, we'll have to change this point in the policy. So yeah, but I cannot really play through all the possible scenarios and answer questions how we would engage. Is it possible to proxy calls? I don't understand this question. State traffic blocking. Proxy calls. We supply limited call functionality. You can use your own servers for calls if, for example, your country doesn't allow connection to our servers for whatever reason. How can SimpleX maintain sustainability? I think we answered this question in a live stream. Are there any plans to develop a countermeasure to DPI? I assume by DPI you mean deep packet inspection. I don't think it's possible. I think the only way to prevent blocking on a state level is to create value and to exist in a legal space, because like you should expect like all the countries developed internet kill switches by now, right? Every single country can kill the internet at very short notice, and like there are multiple there are action plans when and how internet will be stopped. So there is no efficient countermeasures to traffic blocking. And the only solution to that is using multiple operators, which is exactly extreme decentralization we're talking about. If your country is too oppressive, rather than being a Western democracy, then you, like some people may laugh at this point. So you can use servers in different countries. So there is no way to because for example, China has been using AI to analyze traffic for quite some time, right? So that's well beyond deep packet inspection. How did SimpleX come to be? At which point you did realize you needed to create a new messenger? We're not building a messenger. SimpleX protocol were designed for freedom of speech. Right. I spent many years of my life in publishing and advertising, and I was leading engineering team at Mail Online. And to me, communication and freedom of speech were the most important things to develop. And I could see how people are getting fired from their jobs because they say something that their employer disagrees with. They don't break laws, right? You remember this Occupy Wall Street movement. How many people lost their jobs without any records? Or then people go to protests and their bank accounts get blocked. Privacy is paramount for freedom of speech, right? So they didn't break any laws. Or, for example, the previous US administration were Putin on a terror watch, like people who criticized Kamala Harris. That's not a joke. That's what was happening, and we don't know if the new administration is not going to do the same, right? Hopefully it won't. We hope that it won't do anything like that because it criticizes that. But ultimately, what we understand, if we want to have freedom of speech, we have to have privacy. I think it was Oscar Wilde who said, "If you want to hear the truth, give men a mask." Right? People, when they are anonymous, they're more likely to say the truth. So the whole motivation for SimpleX was to design the way to broadcast content without being identified. And it is like, and obviously when we design this protocol, we say, all right, okay, it looks like a messenger. Obviously, it's based on messaging. Why don't we build a messaging first? Respectively, I think it may have been a mistake because messenger is exceptionally complex product. But yeah. I consider creating a private analog of GCM to reduce client-side power consumption. Possibly. You're talking about notifications. We have lots of potential to reduce client-side power consumption without going this way, and we'll exhaust the possibilities for power consumption reduction before we apply other measures. So it is possible there is, for example, a unified push that we could use, or we could use some other approach, but we want to exhaust the possibility for power consumption reduction with the existing design. Calls in the desktop work via browser. Yes, it will be changed, of course. How is the structure of SimpleX database organized? If I delete a group or a file, are there any traces left behind? We put effort to have deletion as a full deletion. Mistakes happen. We fix them every time we discover them. You are more than welcome to validate this, but we put a lot of effort to delete everything. So for example, files attached to the message, and when message is deleted, file is deleted as well. What's important about file storage in SimpleX, I don't know any other app that does it this way, right? So every single app that has encrypted file storage encrypts all files with one key, application key, which means that if somebody steals the file and later steals the key, they can decrypt the file, locally encrypted. Right? So we do it differently. We encrypt each file in the app storage with a different key that's attached to the message. There is absolutely impossible that message is deleted and file key is not deleted because it's literally the same record that contains message content and the file key. So if you have a message with a file attached to it and you delete the message, the file becomes, even if application for some reason fails to delete the file, the application, there was no way to decrypt this file because the key is irreversibly lost to this file. Even though there is a code to delete this file, there is. So we put a lot of effort for deletion to be thorough and complete and exhaustive. And even the last beta release fixed some issues with group deletions. Like there was some trace data from legacy groups, not from current group design, but from legacy group design. We fixed it. So yes, we're very thorough when it comes to deletion because users have to absolutely control information on their device. Will there be a feature to export chat? Maybe. What is the plan for multi-device support in one account? How is it going to work technically? When are you planning to finish implementing it? Oof, that's a big one. There is a problem with multi-device support. The way it's implemented in many somewhat secure messenger creates a backdoor, effectively. When the ability to add a second device can be used to effectively infiltrate the conversation via the operator, and that's very worrying. We don't want to replicate any of that. But fundamentally, there are few choices, right? So like, for example, Signal and WhatsApp do multi-device in this way. Effectively, every conversation is a group, and every time you add a device, all your contacts become groups. Right? And every time your contact adds a device, they also effectively all participate in the same group. You can do it manually today by adding multiple people devices in a group. It's possible to make this approach secure, and maybe we'll go this way. The problem is that your contacts know which device you're messaging with from, and that kind of compromises your privacy. So that's one of the approaches. Another approach is to make an encryption state hosted on the server in a way server can't access it. We're considering that. So we will publish a document about multi-device. I think in the near future, what we can do is to remove the restriction that devices must be on the same network. That's rather easily solvable. A proper multi-device you're talking about, when one profile is accessible from multiple devices and there is no main host device, as it is now, it's a complex cryptographic problem that's fundamentally not solved in the industry. I don't think this year we can tackle it. We will revisit it next year. I think this year we can tackle the same network restriction. Right, a lot of media files have the problem running out of disk space, kind of manager for point-in-time trash removal. Gallery. Yes, there will be gallery. We'll think about to do with the storage space. Do you think you're on a cusp? Do you keep statistics of interest? I think they're very far from being prominent. I think they're very popular in privacy community. I think at this point, SimpleX chat is some compromise between privacy and usability. You get more privacy, you get less usability. So. Please describe the problem that the user should be aware of when starting to do database backups. For example, if you do a backup rarely, once in several months here, what will break on restore rather than not having new messages? Or you first restore an old backup and then file, right, okay, yes. So obviously backups contain cryptographic keys. Keys change because of break and recovery. If you use very old backup, you may be in a situation that some of your connections will be disrupted. You've seen it in the chats when you have to fix encryption. We are going to look in the problem of automating and making backups more regular to make it more usable. But we will make it better, but it's also a complex problem. How long do they live in Russia? It's completely irrelevant. I'm not going to answer my personal questions. I see the implementation of quantum-resistant encryption. In your view, why is this important? Why do some connections, such as colon connections between group members, use simple end-to-end encryption for performance? Right. Okay. So we have made a very good blog post, I think, about quantum-resistant encryption. And on one hand, and many people see quantum-resistant encryption as premature and unnecessary because A, we don't have commercially viable quantum computers and nobody knows when we're going to have them, right? It's almost like we are, with quantum computers, I think we're pretty much in the same spot when we've been with AI 30 years ago, right? Because I remember when I was like 20 years old or 15 years old, I was reading news in the newspapers that we're going to have a general purpose AI in 5 years. I think it's about venture funding, right? You have to say that you're going to build it in 5 years, otherwise nobody will give you any money, right? And then I've heard this like general AI in 5 years for the last 30 years, and now we're here. So I think with quantum computers, we're pretty much like in the first decades out of several. So I don't know when we're going to have, nobody knows. So on another hand, quantum-resistant algorithms are not bulletproofs. They are not proven. They are so effectively it's a solution to a problem that we don't have, and nobody has a guarantee that this solution will work. So the question why bother is a very correct question to ask. But at the same time, we know that record now, decrypt later attacks aren't going. There are huge data centers that capture traffic and that's preserved for a very long time, particularly for some people. And people are generally concerned about this record now, decrypt later attack on the off chance that quantum computers are available in say 5 years or 10 years time. So, and also if quantum encryption is used not instead of traditional encryption, but in addition to traditional encryption, it can't hurt, right? It may not make things better, but it can't hurt. And that's exactly how it's applied today. It's applied in a hybrid scheme, not replacing traditional encryption, but augmenting traditional encryption. And at worst, it's unhelpful. At best, it's helpful. So there is no downside other than the key size, right? And that's the reason why we don't do it in groups. The algorithms are slow, and the keys consume space. We're going to add quantum-resistant encryption to groups of up to 20 people, that is small groups. There is no real possibility to or reason to add quantum-resistant encryption to public groups just because like anybody can join. Content is not public. Content is public anyway, and it is prohibitively expensive computationally. Front end for the web for public channels, quite possible. Yes, we considered that. There may be a view-only interface for public channels. Financial profit model, I commented on that. Massive emphasis on privacy and security. Why there isn't an option to allow messages to delete on the recipient device upon delivery as opposed to when it's read. Edgy speaking. I don't understand the question. There is so effectively we think that message deletion should be responsibility of the message recipient if they want to, and ultimately we're trying to balance reliability and privacy rather than make something that's completely unusable. Deleting messages, like sender can delete message if the conversation allows it, and we believe that it's important that device owners are in control of the messages they receive. So deleting something that's not even read feels wrong for majority of conversations model, but we will get back to this ideas. Flux, we have a question for you. I don't know if you're in the group. Aren't you concerned about using a high percentage of the hosting provider Hertzner? Do you understand the question?
What they're asking is about VPS providers that we that are utilized by our users. No, we're not concerned about that. Essentially, with Arcane, everything's encrypted end to end, and really, honestly, our node operators and/or the providers are really out of the loop. To build a better, more secure platform, we had to ensure that user data and information was protected, encrypted, and that's exactly what we did. So if you look at Flux's spread, there's 900 plus providers across the globe. Are there some VPSs combined in there? Absolutely. And we obviously prefer home hosting, but not everybody has a network infrastructure in their basement. Because Flux infrastructure requires very high compute resources. So that was a long answer to your question of saying no, we're not concerned about that. I mean, obviously, as we continue to iterate and grow forward, home hosting will be definitely the focus moving forward, but there are some VPS providers included in that.
Right. Good. You talked a lot about this question to me again, SimpleX compliance with the law to keep communication private in light of the Telegram situation. What do you think about that? I never thought anything, like Telegram is great for content distribution. It never was a private messenger. I think Pavel's mistake was to advertise something as private, which wasn't private, right? I think whatever you do, you shouldn't be lying to your users, right? That's first thing, right? And I think the fact that Telegram was blatantly lying to its users about its privacy and security parameters was causing criticisms from everybody, right? Both privacy community and everybody and technologists. Like you should know, whatever you do, you don't have to do what users like, but you can't lie to the users, right? And I think the fact that Telegram decided that it's okay to build a marketing campaign around misleading users is the root cause of its undoing, right? And also the second problem with Telegram, they knew about criminal activity galore on their platform, and they did absolutely not. It's like almost Facebook. Like there is a court case in like how many 20 states now that prosecute Meta for child trafficking and abuse. And not only they did nothing, they enabled traffic from child abusers to children on Facebook. And on what planet it's acceptable? And whenever there was a conversation inside Meta, according to those lawsuits, they refused to do anything. That's ridiculous. And Telegram wasn't particularly different, right? They knew about child trafficking and abuse on their platforms. Conversations are not encrypted. They did absolutely nothing to do it. So I think you can see that how our position on this matter is very different. We are very small. We do not have anywhere near as much abuse and on the platform, but we want to take preventive actions and make it technically impossible before it becomes a problem, before it becomes a reason to criticize us for doing nothing to prevent serious crimes. So I don't know. I think you just have to be honest with your users and do what's right, whether users like it or not, and somehow communicate with the users as we are doing now and explain why we're doing what we're doing. And if you do the right thing, that maybe the right thing will happen in return. That's all very simple. So is there any development plan for bots? Yes, absolutely. We are halfway through building a Node.js library for bots. I know that it's really hard to build bots right now. We offer Haskell library. Nobody wants to code Haskell other than us. I know that. Or we say, okay, use WebSockets. Highly difficult. Like, we think that Node.js library will make it simple to create bots. We really wanted to make it simple to create bots. But at the same time, we see a lot of abuse by bots in the groups already, so it's beginning to happen. So we kind of have to combine our measures, like simplicity to develop bots has to be combined with ability to prevent bots in the groups where those bots are not desirable. So that has to go hand in hand. So yeah, both things will be happening. Implications of having your own server. There is a threat model that describes it. Obviously, it's privacy versus control, right? So if you have your own server, it will have little traffic. It means that traffic can be monitored, and it's rather easy to establish who communicates with whom if server translates very few messages. So that's but you're in control, right? You can host your server on Tor, or you can have your closed network and nobody exists, and you wouldn't have operators have an opinion about what's acceptable or not acceptable. So it's effectively privacy versus control. By using your own low traffic SimpleX server, you're trading more control for less privacy. That's the implication. Look at the threat model via the white paper, and you will see all the kind of ups and downs, or pros and cons of having your own server. You said that the file still persists even if one operator removes it from the server. Shouldn't it be enough for one operator to take chunks of the file? Right now, yes. That's how it works, because each chunk is uploaded once, right? So we currently don't have redundancy in file upload. And when you send a file, we spread a file across multiple servers, but each chunk is uploaded once. But the design of the protocol, the design of the file manifest that's sent between clients allows to upload the same chunk. Effectively, we are planning to build the functionality that would allow to send files across more than one service, both for technical reliability and for censorship resistance. And on the core level, this redundancy is already supported, and part of the code would support this redundancy out of the box today. So we thought about this from the day one, and obviously the trade-off here is you want to send 100 megabytes file, now you need to upload 200 megabytes data. But if you want censorship resistance, that may be what you want. So when we say extreme decentralization, we assume that we are moving to the world when traffic is cheaper, and if you want to protect something from censorship, you will just upload it across multiple operators, and not just one chunk per operator. No, I mean, every chunk will be uploaded to 3 different operators, let's say. And if one operator decides to censor it, that would have zero effect, because the client that wants to download will try the first chunk. Okay, it's not there, it will try the second chunk. The same goes with Flux and our servers, right? Today, you connect to somebody, you choose one server. We have about 80% redundancy implemented in the client, simple 80%. We don't have complex 20% implemented. That would allow to send each message through 2 different delivery paths. And it also may have some privacy implications so we are not rushing it. So it has to be carefully done to avoid privacy implications. But yes, fundamentally, when we talk about extreme decentralization, we talk about redundant usage of multiple operators. How are you protecting client IPs when using audio-video calls? When you use relay, then relay can see your IP addresses, but your peer cannot see your IP address. But other than that, obviously, if you use relay for calls, turn server, then the server can see your address. Where does he read the question from? From the group. Okay, right. I think we had a huge number of questions. Feel free to send questions later, and we'll try to answer them privately. It's been almost 90 minutes. And Dan, thanks a lot for joining us today. That's fantastic. And thanks so much for all your support. All right. I think we're ready to call it a day.
All right. Well, I appreciate you having me on, man. And I mentioned in the YouTube chat as well, if there's anybody that has questions, comments, input, feel free to reach out to either of us. We love creative, constructive criticisms. So let's just all work together to get this to the next level. So thank you again for having me on. I truly believe in what you're doing. I truly believe in this project. I think that these are the kind of things that we all need to get behind and support. Otherwise, we're going to give away our freedoms. Slowly and surely, they will be chipped away at. So let's govern with code, and that's exactly what we're looking to do long term. So thanks again for having me on.
Thank you, Dan. Thanks for joining, and thanks for supporting SimpleX Network. And we'll answer questions in YouTube or Twitter later. We've been broadcasting it through. Most people joined on Twitter, as I can see, but there's been also on our site. And more than 1,000 people joined on Twitter. This is crazy.
I think we were up over 1,600 at one point
Yeah,
in time. So that's a darn good turnout, man. You're definitely popular.
No, I don't think so. That's all right. 1,700 people on Twitter. That's fantastic. Yeah, I didn't realize. And yeah, but also on our site. So whoever didn't like X for whatever reasons could watch it on our site. Thanks everybody. Thanks for joining. The recording will be available later. And then goodbye, everybody. Goodbye. We're disconnecting. Thanks. Let me stop the broadcast. Where is the button?